Welcome class. Today we are talking about functions, so 1.4 and graphing functions or evaluating functions 1.5. Okay, so we're talking about functions and we're going to analyze them. So if you want to follow along the book, we're actually going to go pretty close to the definitions found in the book, but nevertheless, I want to explain it. So there's some key definitions we need to see from 1.4 and 1.5. You might already know them, so I'm going to go over them briefly. And let's zoom in so that we are on screen. So a relation is a mathematical rule that of correspondence. Sorry. So this is corresponding to two things together. It can correspond, for example, weather patterns to crop rotations or things like this, where in fact it can sometimes be a function, which in fact is the definition, the key definition we'll talk about. We're actually going to go into the thing, so this is just a reference point. So the definition of a function, and if you have any questions over this, so a function f from set A from A set A, not from set A, from A set A to A set B is a relation that assigns to each element x in the set A exactly one element y in set B. We'll talk about what this means. I'm just going to go through it. The set A is the domain. The set of inputs. Inputs. I always put inputs. And the set B is the range, or the set of outputs. Okay? So essentially, you're going to have a set A of numbers. Okay, 1, 2. And actually, it doesn't have to be numbers for a function to work. You're going to have set B. Okay, B, let's say 3, 7, root 2, 4. Now, this element are the x terms we're talking about. Each of them needs to pass to exactly one element. Okay, so this is a function because each of these corresponds with one output. Can two inputs correspond to one output? Absolutely. But they cannot, one of these can't correspond to two different outputs. So example, this is a function. What wouldn't be a function, this is not a function, 1, 2, 3, and let's say this is 3, 4, 5. So if 1 corresponded with 1, if 2 corresponded with two different things, if 3 corresponded with 1, this would not a function. This is a function, okay? So do you see how there's one arrow from each of these numbers? That's a function. If there's two arrows, that means it's not a function, okay? So you know a function based on the relation that an x has only one y versus not a function is going to have an x have more than one y. Okay, let's keep moving on. Characteristics of a function. Let's just tone this down a little bit. Each element in A must match. We've already said this stuff, but Okay, so write it with an element in B. Some elements in B need not be matched with any element in A. Okay, so this is possible. It doesn't have to be. It can be everything. Sorry. Else is slipping. Okay. And then 2 or more elements in A matched with the same element in B. And finally, so these might be. They're not all, they don't require it to be all of them, but they could be. In A, the domain cannot be matched with 2 different elements in B. Okay, so again, you might have, some of B might not be matched, but an element in A can't match to 2 different elements in B. Okay, 4 ways to represent a function. Okay, so let's talk about 4 ways. We can talk about it verbally. So let's just get some italicized verbally. So this is the relation. You can talk about numerically. Sorry that I have hiccups. And this would be with a table. Okay. You can talk about it graphically. So this is with the horizontal with the inputs and vertical with outputs. And then finally, we'll talk about algebraic. Like normally, we're going to be doing it algebraically, where it's an equation of 2 variables. Okay, so let's look at these 2 to see if they're functions. The input value x is the number of representatives from a state. The output is the number of senators. So, how many representatives you have a state corresponds with the number of senators. Now, can any number of representatives be to a different number of senators? Well, that's a good question. If you have a different number of representatives, how many senators do we always have? We always have the same number of senators, 2. So yeah, you could have 2. You could have representatives, like 2 representatives, but they're always going to correspond to 2 senators because each state has 2 senators, but they have different number of representatives based on population. Okay, so the senator stays the same, whereas representatives might change. So that would imply it would be kind of like this situation where it's a horizontal line. And is a horizontal line a function? Yes, it's a function with no slope, but it's still a function. Is this table going to be a function? Well, let's look at it. We have 2, output is 11. 2, output is 10. 3, output is 8. 4, output is 5. Now the problem is 2 corresponds with 2 different outputs. Okay, so that would mean that this is not a function. Okay, and then 5 corresponds. Okay, what about points on a graph? Okay, well, actually this is in the book, so we'll look at this briefly. So do you see this little thing right here? We can increase it, I think. Actually, I always lose track of it. My apologies. Okay, so notice that each of these points is separate. So that would mean that this would be, yes, a function. So you would say it is a function. Okay. What about this one? Well, we can actually rewrite this one. So this can be rewritten as y equals negative x squared plus 1. And is that a function? Well, yeah, each x is going to correspond with a different y. Okay, that is that two outputs don't correspond with two inputs. Okay, or with one input. Okay. Okay, what about this one? So if we rewrite this, we get y squared equals x plus 1. Now notice there's a problem. That is that our y is squared. So if we rewrite this to get y by itself, what do we get? Well, we get y equals plus or minus the square root of x plus 1. Now notice something. Is an output corresponding with two different inputs, or rather, is an input going to correspond with two different outputs? Yes. So if I put a 0 here, that would be 1 plus, so 0 is going to give us two different y values. Okay. So what we say here is this is not a function. Why? Because in set B, we have one element in set A corresponds to two elements in set B. Okay, now this part, 3, 4, and 5, we'll cover next video. So just talking about it, we need to know definition of a function, and then we'll talk about how to solve something. Okay, so we'll move through the rest a little bit quicker. Okay, thank you.